All right, aloha, good morning everyone. Thanks so much for joining me for our first live virtual classroom. Welcome to my home. My name is Robin. I'm the Education Manager at Pacific Whale Foundation. I'm excited to be sharing my virtual classroom with you today since I can't be sharing the classroom I normally might be this time of year. Normally we'd be wrapping up our Keiki Whale Watch season. Our Keiki Whale Watch program is one of my favorites. This is a program where we get to take students out on whale watches and share a little bit of education and activities about humpback whales. So while I can't bring any real whales to you today, I'm hoping to bring just a little bit of education about humpback whales and a fun activity or a mini experiment actually today to you. So I hope that there's something in here for everybody. I know I've got all kinds of classes joining me, family, friends. There's all kinds of things here for you, hopefully to keep your brain entertained. That's kind of the goal. And while I can't bring real whales to you, our Eco Tours team has been hard at work to try to bring some virtual Eco Tours to you. So that's something that you can check out after this. If you're just joining us, if you haven't seen the materials list, if you want to join in the fun in the activity today, I did put out a little materials list. Each time I do these virtual live classrooms, I'm going to try to make sure that there's something that you can do with me as some sort of fun activity, and that you can do this with things that you have at home. I don't want you to be having to waste any food or any other items. I don't want you to have to be going out and buying materials for this. Please don't do that. So for today, all that we're going to need is a little bit of paper, maybe 1 or 2 sheets, or really 2 sheets probably would be best. Any kind of paper is just fine. Scissors and tape, that's all that you're going to need today to join me. So if you haven't grabbed that, you can grab that now. I'll put the view back up a little bit larger on myself for now. So today's topic is humpback whales, but not quite all about humpback whales. We have to pick something a little bit more specific. There's a lot that we could talk about humpback whales. Likewise, there's a lot we don't know actually. They're very interesting animals. Start off by showing you my model here. Now, of course, this is not to scale. This is not a life-size model of a humpback whale, but hopefully gives us a good idea of what they look like. Humpback whales in real life, when fully grown, can be about 40 to 45 feet long. That's about the length of a big yellow school bus. Anybody remember what those look like? Sadly, I know it's been a while since we've seen them. And humpback whales are very heavy as well. They can weigh about 35 to 40 tons. They're about 70,000 to 80,000 pounds. And if you want something familiar to compare that to, that's about the equivalent of 7 African elephants. Just for fun, I like to picture the elephants in the bus. It's an awkward image, but it gives you an idea about how large and how heavy a humpback whale is. So like I said, we can't focus on everything about a humpback whale today, but just a few things, or really one in particular. But first, a little bit background. This may or may not surprise you, but we actually have a lot in common with humpback whales. Clearly, we look about the same, right? Okay, maybe not so much, and of course in real life they are a lot bigger than us, but we do have quite a few things in common. One of those things, we're both mammals, and so we share all those characteristics that all of the mammals share. So one of those is that we're warm-blooded, so that means that we can regulate our body temperature rather than taking on the temperature of our surroundings. Another is that we give live birth, and with that we also nurse our young. And all mammals have hair or fur on their bodies at some point in their lives. And finally, they all breathe air. So humpback whales are actually marine mammals. So like us, they have all those mammal characteristics, but they have some extra adaptations that allow them to live in the water. Internally, we have a lot of similarities too. One of those is our skeleton or our bones. Humpback whales actually have a lot of the same bones that we do. One area I want to focus on, and really the area we're going to focus on for the rest of this session today, is their pectoral fins, or flippers. We can use that word interchangeably, whichever you prefer. These fins or flippers are actually very similar to our arms in terms of the bones that they have within them. So I'm actually going to do my best to hold up a photo and show you. It'll take me just a little bit to get it into the right place. Please bear with me. I'm learning how to juggle with the camera here. So if you can see this image on the, oh gosh, I don't know which side to tell you. There's a human arm and there's a marine mammal arm or fin or flipper as well, a pectoral fin. And that color coding shows you some of the different types of bones that are found in there. And you can see that the proportions are much different in the human arm and the pectoral fin, but the types of bones that are there are the same. Humpback whales do have one fewer finger than we do. So hopefully you were able to see that. I apologize. I'm getting used to doing all of this stuff on my own and all of the technology. Those of you, I know I have some high school marine science students in here. That's something that you could look into a little bit further, is some of the internal anatomy of humpback whales, that pectoral fin in particular. What we're going to focus on is a little bit different today. So these pectoral fins or flippers, humpback whales don't use these to get around actually. That's usually when I have an actual class in front of me, when I can see everybody, I usually ask, what do they use them for? And everyone shouts out, move, to get around. And that's actually not what they use them for. So their tail, or their flukes, are what they use to propel themselves through the water. They move that up and down. These pectoral fins are more so for agility. So they can use these for stopping or steering. They can use these to maintain their position, to stay in one place, but not really to get around. So not actually like wings, although that is where they got their scientific name. So before I even try to say that, I'm going to show it to you and make that a little bit easier. So there we have that. So right here you can see their scientific name. Just underneath is a little help with the pronunciation if you need it. Megaterra novi anglii. And what that means is big-winged New Englander. So they actually got their scientific name for these wing-like appendages for these pectoral fins. And the reason it says New Englander is that was the first area where they were observed off the New England coast. So some fun facts about these pectoral fins or flippers. Now one thing that's extra kind of unique about them are the bumps on the leading edge, or that front edge of the pectoral fins. And these bumps are actually part of a special design. These are the same type of bumps as the bumps that the humpback whale has on its face, on its upper jaw. They're called tubercles. And these bumps are about the size of a golf ball. And it's actually been found that these bumps really help the whale move through the water. So all marine mammals have a nice streamlined body, nice and smooth, nothing sticking out that would slow them down or produce drag. But these bumps, which you might find weird and actually not expect to be helpful at all, actually increase lift and decrease drag for the whale moving through the water. And these seem to be so effective that people have actually started to study them and started to model things after them. So at some point in the future, we might see airplane wings that look a lot like pectoral fins. This has already kind of been incorporated into some wind turbine design, even fan blades, propellers. So pretty unique, pretty special design that humpback whales have. So today I wanted to do a mini experiment that I think will be fun for all of us. And there's a lot of room to kind of take that further. So those of you that are in more upper level science classes that you want to do a little something more with this, I'll try to throw in some ideas of other things that you can do with it. We're going to do a pretty simple mini experiment to kind of get an idea of how this design is helpful for aerodynamics, right? We're not going to do anything underwater today. And we're going to keep it pretty simple. Remember, we're working with paper. So what we're actually going to do is create what I have decided to call a whale plane. And again, pretty simple. It's a paper airplane that we're going to make look a little bit like a whale, that we're going to give some pectoral fins so we can make our own observations of how something like a pectoral fin might assist in flight on something like a plane. So now is the time where you're going to need your paper, or where your paper would be helpful. So I'm going to go ahead and get my workspace prepared over here and get my sheet of paper Normally I do work with scrap paper. For this, I'm going to work with a blank sheet of paper because I want to make sure that you can see what I'm doing. So I'm going to go ahead and grab my sheet of paper, bring it over to where you can see it. Make sure we're in focus here. Now, if you have your own way that you like to make a paper airplane, please, by all means, make your own. It's kind of more fun when we all do things different. But for those of you that either need a little refresher or need to see how to make a paper airplane, I'm going to go ahead and demonstrate that for you, the method that I typically use, which is kind of your standard paper airplane. So I'm starting with my sheet of paper. The first thing I'm going to do is fold it in half the long way, or hot dog style. So fold it in half the long way or hot dog style. Make that nice crease there. And then open your paper back up. Now, the first thing I'm going to do is take one corner, and it doesn't matter which corner you work with. We're going to do the same thing with both corners. So take one corner and fold it down towards the center crease. You're going to make this whole top edge meet the center crease here. So I'll try to do that as slowly as I can so that you can see, and then make sure I give you time to do yours as well. Okay, so that's the first, or really I should say the second step, was folding down that first corner. Now we're going to do the same thing with the other corner, so we're going to make those meet in the middle. So I'm going to take that corner and fold it down to that center crease as well. Okay, so now you should have something that looks like this, and these flaps are on the top. Now, flip it over so the flaps are underneath. Waiting for it to come back into focus. There we go. And now you're going to fold it in half again the long way, just like you did before, hot dog style. So you're using the same fold. You're basically just folding it in the opposite direction. So you should be able to kind of use that same crease and just bend it the other way. Okay. I like to make mine as perfect as possible, but I think that is impossible. So we'll do the best we can. Now we're going to do essentially the same thing as we did before. We're going to take this top corner here, and we're going to fold it towards the center crease, making again the whole top edge meet the center. And fold. So again, we took that side and we folded it down to the center. Now flip the whole thing over and do the exact same thing on the other side. Take this corner and this edge and bring them down to the middle. And then we're going to do the same thing one more time. So we're going to take now, it's pretty much this whole outside edge that we're bringing to meet that middle fold there. And I'm trying to keep an eye on the comments here. I saw a how a while ago and then an O, so I'm hoping that we figured it out. I do have a little bit of a delay between what you're seeing, so I'll try to keep checking the comments and make sure I catch up with all of you. One more step here. We're going to flip it over and do the same fold on the other side. So we're basically now folding this last side in half here. And then we've got a plane. We've got a paper airplane. And I like this design because it's pretty streamlined. So it doesn't really have any flaps sticking out anywhere or any folds on the top. So maybe that'll help its flight. So hopefully you've created your plane, whether it's my design or your own design. Now, I said we're going to do a mini experiment, right? We only have so much time that we can spend together, so we can't do a very full, very professional experiment. So we're going to keep it pretty simple. Anytime we're doing an experiment, anytime we're testing the effect something has on something else, we need to be able to compare that to something. We need to have a control. So in this experiment, are plain, not really meant to be a play on words there, but the plane, the regular paper airplane, is the control. This is kind of the starting off point. So if we want to test how pectoral fins impact how it flies, we need to know how it flies first without the pectoral fins. So we're just going to do a few test runs. It's important that we pay attention to keeping as many other things the same as we can. So we want to keep our starting point the same, and we want to keep the strength that we throw it as best we can the same, and all the other conditions the same. So I'm going to go to a starting point that I know I can get back to every time. It's the edge of my living room rug, so you can pick out your own starting point. I'm going to do 3 test flights, and I'll talk through it as I do that, but just so you know what's going to happen next. And I'm going to try to mark where it lands every time. You could use a little bit of the tape that was on our materials list if you have that, or you could use some toys that you have in the house or something else. You could put a cup, you could put a plastic figurine, a Lego, whatever you have around. Just mark your spot where it landed, and also really pay attention to how it flies. So I'm really going to try to take note of, did it go straight up, did it go straight down, how fast was it going? These are difficult things we're observing, we're not measuring, but do the best you can to really pay attention to how it flies. So I'm going to go to my starting point that I can get back to every time, and here's my first test flight. Not super impressive if you saw that, and it didn't go very far, but I will make sure I mark that spot where it landed. It's embarrassing that you can see how not far it went. And I'm going to do another test flight from the same spot. Try to get it to go maybe a little bit better or further this time. One in the other direction, also not so far. I'm going to go ahead and mark that spot. And I'm going to try one more test flight. That was a little bit better, so excuse me while I go mark that spot. Okay, so I got a feel for how this flies. I have some observations. Not the best experiment, right? Again, this is sort of a mini experiment here. Oh, I see a question there. What grade do I teach? Well, over the years, I've actually taught just about every grade. I started my teaching career in high school science, and now in my job, I get to teach just about all of the grades. And so what we're doing here is trying to keep it kind of simple and light and fun for anyone or any grade that wants to join us, and hopefully you can take it a little bit further afterwards. So this mini experiment that we're doing here is something that you could do a much more in-depth experiment with later on if you like, or turn it into an engineering design challenge as well. Throw it towards pictures. I'm not working on the aim here, but anyway, I have some observations on my test flights, and so hopefully you've thought about how your test flights went too. It went pretty fast. It was a little bit jerky. I'm going to try to really keep that in mind, and now we're going to move on to create our pectoral fins so that we can get to the fun or the experiment part of our experiment. So just to give you an idea of size, of course this is your experiment and you can design these however you like. But just to give you an idea of the size, this is my humpback whale model, and this is my paper airplane. So they're almost similar in length. My whale model's a little bit longer. But to give you an idea of what these pectoral fins on the model look like compared to the airplane, but again, use whatever design you like. I made mine pretty similar, and I was working with a 1/4 sheet of paper. So I'm going to show you mine here. So you can design yours however you like, but it's important you try to incorporate something like the tubercles, right? That's kind of the feature that we're talking about, these bumps and how they help increase lift and decrease drag. So you want to try to incorporate something that would be like the bumps of the tubercles. If you want to work smart, as I like to say, you might want to fold the paper you're working with in half, and then you only have to cut it out one time, and you'll have 2 perfectly symmetrical pectoral fins. So I'm going to go ahead and start to cut mine out. And while I'm doing that, I have some time if we have questions about maybe what we're doing so far or about humpback whales. This might be a good time for me to multitask and answer questions while we're cutting, while we're working on this. So feel free to send them. If not, I certainly have plenty of fun whale facts that I I can share with you. And if you got lost anywhere making the plane or doing your test runs, I believe that you can rewind the video to get to whatever place you need, so that hopefully you can stay with us. All right, I don't see any questions yet, so a little bit about these pectoral fins. I believe I mentioned their size, but I'm not actually certain, so I definitely want to make sure I let you know. In real life, a humpback whale's pectoral fins can be about 1/3 of their body length, or up to about 15 feet long. And coincidentally, thanks guys, thanks for your support with the fun facts. Coincidentally, 15 is kind of we call it the magic number for humpback whales. It's the answer to a lot of questions we might ask. Humpback whale's tail or flukes can also be about 15 feet wide. And a humpback whale, when it's first born, or a calf, can be about 15 feet long, so about the length of its mother's pectoral flippers. And humpback whales actually come here to Hawaii for their breeding season. All right, I have cut out my 2 pectoral fins, so I'm just about ready to go, but I'm gonna give you just a little bit more time in case you need it to create yours, and I'll take a look over here at the chat. So, great question. How does the plane relate to a whale? Well, so this is more of the kind of test with the engineering design. So we're talking about how these traits, these pectoral fins and their tubercles, are beneficial for a whale to move through the water. So the best experiment that we can do, or that I can think of to do with pretty simple materials, is to translate that to the airplane and see how the pectoral fins work on the paper airplane. And I'll get to some of the challenges from that a little bit later on. And I'm going to come back to some of those questions a little bit later on too, so I don't get too far removed from our experiment here. So I'm going to switch the view back, and hopefully you are finished or about finished with your pectoral fins so that you can attach them to your plane. Now is when we're going to need our tape, if you don't already have that over there. So you can see I've got my paper airplane laid out, and I've got my pectoral fins laid out, and I've got my tubercle side, the bumpy side, facing forward. So now I have to give a little thought to where I put these on my paper airplane, and this is part of the experiment. You can place them however and wherever you like, but keep the tubercles, keep the leading edge facing forward. So think about where you might want to place them on here. You can place them kind of towards the front of the body, where they are on a humpback whale. You could place them right at the center. You could try placing them further towards the back. I don't have the answer for you on what that's going to do. You can also think about, you want to place them both sticking straight out or perpendicular? Do you want to put them on an angle forward, on an angle backward, or on different angles? So that's up to you, and that's kind of exciting. I wish I could see what all of you are experimenting with. For my purposes, I'm going to keep it symmetrical right now. So I'm going to attach them about in the middle, and I'm going to attach them a little bit on an angle to the back. I'm going to see what happens there. So I'm going to go ahead and tape those on as symmetrically as I can. And so now you can see my completed whale plane here. So hopefully you're with me, or pretty close to with me, so you're ready to do some more test flights. So again, I'm going to start from the same spot. I'm always going to mark where it lands, and I'm really going to try to pay attention to how it flies and think about how that's different from how it flew before. So back to my starting place again. Here we go. Oh, interesting. Kind of went straight down and then got some lift and a nice little glide. So I'm going to go mark that real quick. All right, next test run. Not quite as far, but a lot of glide. It actually went up, or lift, you might say. All right, we'll do one more test flight. Again, not so far, it kind of went to the side, but lots of lift. So those would be my observations from my mini experiment, was that these did actually help it get some lift. Now, of course, I do understand that this is very different than a humpback whale, very different than an airplane, and pretty much a two-dimensional model, right? So I did create the bumps, but they're not three-dimensional. So one of my challenges that I would give you if you want to take this experiment further is see if there's a way to make those bumps a little bit more three-dimensional. See if there's a way you can improve your design, and what are you going for? Keep that in mind when you're looking to improve your design. Do you want to see how far you can get it to go? Do you want to see how high you can get it to go? Or I have a challenge for you because pectoral fins are used by humpback whales for steering. Can you get the pectoral fins to steer the plane? Can you get the pectoral fins to make it turn? I don't care which way, left or right, but give that a try. So those are some things I would challenge you to do. If you want to keep it a little bit simpler, you really like your whale plane how it is, maybe decorate it. Make it look like a humpback whale. Also, you might want to do a little bit of research. Look into how they're applying this design in real life, or look into other examples of this. Humpback whales aren't the only animal that have inspired designs for humans. So take a look into that and see what you can find out. I hope you enjoyed that activity, that experiment. I will put up the materials list for next time as I get to some questions, because one of your questions has to do with what we're going to cover next time. So you can see this list is a little bit longer than today's list. This will be for Tuesday, April 7th, same time. So if it was 9 a.m. for you today, it'll be 9 a.m. again. If it was noon, if it was 3, same thing on Tuesday. And we are going to get to what humpback whales eat. So I know somebody asked that. So we're going to talk a little bit more about their feeding methods, and not just humpback whales, but some other marine mammals as well. Please, if you look at the materials list, get creative. Think about what you could substitute for any of these things. The intention is not to have to go buy anything or waste anything that's of importance to us. So please keep that in mind. Let's see some of the questions. Oh, Katie, about my career path. Well, I don't know how long I can talk about my career path, but just to give you guys an idea of a little bit of my background, I started my career working for Pacific Whale Foundation, actually, as a naturalist on our eco tours. So I was getting to educate. I also got to work with our research team a little bit. And of course, I wanted to, stay in the marine environment forever. But I did really enjoy teaching. So I actually went back to graduate school. I got my master's degree in science education. And that's where I was teaching formally. I taught middle school science, high school science, and I also taught 3rd and 4th grade before transitioning back to Pacific Whale Foundation in the position that I'm in today. So I've enjoyed all of it. It's been a really cool trip to get me to where I am. And although this is very different than what I expected to be doing right now, I'm really excited to be kind of sharing what I do and sharing some fun with you guys right now. Our whole team is working really hard on things to entertain your brains during this time. So please check in with us. You can find us on Facebook or Instagram. Find some of the other things that we've got going on. If you want to share any of your questions that I didn't get to, you want to share your whale plane experiment with me or your engineering design, show me your whale plane that you got to make a turn, feel free to do that by email at education@pacificwhale.org. I don't see any other questions on there, so I'm going to tune out for now, but thanks so much for joining me this morning, and I hope to see you all back here again on Tuesday. Aloha!